The Benedict's test for reducing sugars. Using a wax pencil and ruler, mark 3 centimeters and 6 centimeters up the test tube. 3 centimeters approximately equals 3 milliliters. Add 3 milliliters of test solution. Then add 3 milliliters of Benedict's reagent. The solution should now be blue because the Benedict's reagent is blue. Shake to mix. Place the test tube into a hot water bath you started at the beginning of the experiment. The heat catalyzes the reaction. If reducing sugars are present in the test solution, there will be a color change. The color the solution turns depends on the concentration of reducing sugars in the test solution. What happened? If we look at the components of the starting solution, we see 2 important parts. One is the reducing sugar. You can tell it's a reducing sugar because of the free carbonyl present when the ring is open. The reducing sugars have electrons in their structures. These are represented by the dot within the ring. We can also see copper-2 ions in the solution. These are part of the Benedict's reagent and are blue in color. The copper-2 ions interact with the free carbonyl groups of the reducing sugars. An electron from the reducing sugar is transferred to the copper-2, reducing it to copper-1. Copper-2 is reduced to copper-1 because any gain of electrons is reduction. Note that copper-1 ions are rust red in color. This is what causes the solution to start changing color, the production of copper-1 ions. At the same time, the free carbonyl group of the reducing sugar is oxidized to a carboxyl group. The carboxyl's OH is picked up from the surrounding solution. The reducing sugar is now an acid sugar. The process is repeated. An electron is transferred from the reducing sugar. Copper-2 is reduced to copper-1 and turns rust red. The free carbonyl is oxidized to a carboxyl group, and the reducing sugar becomes an acid sugar. Again, the electron is transferred to copper-2, reducing it to copper-1. If we want to see why the sugar is oxidized, we have to look at the electron distribution in the free carbonyl. You can see by the red color that the electrons are concentrated around the oxygen atom and pulled off the carbon. When the free carbonyl is oxidized, the addition of another oxygen pulls more electron density away from the carbon. You can see the carbon is now blue, meaning low electron density. This is oxidation because any loss of electrons or electron density is oxidation. As more copper-1 ions are formed, more rust red precipitate is present. This turns the solution more rust red in color. So this would be an example of a test solution that has a high concentration of reducing sugars. However, there is a range of colors that can result from the Benedict's test. The concentration of reducing sugars is shown in increasing amounts from left to right. If there are no reducing sugars in the test substance to reduce copper-2 to copper-1, the solution stays blue, the color of copper-2. A trace amount turns the solution blue-green. A small amount turns the solution green. A medium amount turns the solution yellow. A medium-high amount turns the solution orange. And a high amount turns the solution rust red. So the color changes indicate the presence and relative concentration of reducing sugars in a test substance. The colors occur because reducing sugar reduces the copper-2 in the Benedict's reagent to copper-1 rust red precipitate. So that's the basic idea of the Benedict's test for reducing sugars.